Hey guys, this is Alan from Carolan. I'm just going to share a video with you all on something that I've been working on for many years now, but it's finally come to a head where I can actually put it in a production amp. This is what we're looking at now is just it's an experimenter board. Uh, Basically, you can just swap parts around and configure things how you want. What we have here is an OD3. Uh, I've got blue tape all over the back of it because there's a lot of high voltages in there. I'm leaning all around it. I just want to be safe. There's also blue tape here because we have about minus 80 volts coming out of here as well. What we're looking at is an automatic bias circuit that biases the amp itself. It's the next step on from the bias monitor that we have in the amps, where you can the amp monitors a few parameters inside itself, decides on its best bias point, and then you adjust a pot and the LED lights up green when everything's okay. So what we have here is an automated version of that. Basically, you can use whatever tubes you want with this system. You can just put them in and set it off, and it'll automatically bias everything itself. It's got a set of switches here. These are for selecting the tube type. So at the moment it does 6L6s, EL34s and KT88s. Now typically we wouldn't normally use all of those in the same amp, but I'm going to just use a pair of 6L6s to demo this right now. But I'm going to set it up as if I was biasing it for the other two types. It really doesn't matter because the 6L6s can handle the current, so I'm just setting it off like that. So when we first fire the system on, what we need to do, and this might be difficult with me holding the camera, is I need to turn the power on, and I need to hold this button at the same time. So if I just flash around all over the place, I do apologize. So let's turn it on. And if you notice, the green light will flash 3 times. That's basically letting it know that I held the button in as I was powering it on to tell it it's got a new set of tubes in it. So what we do now, turn the amp on. I've got a bias meter here to show what's happening, and because it knows it's got a new set of tubes in, what it does is it drives the negative voltage for the bias down to a safe point, drives it higher to a safe point, so we're not going to cook the tubes as soon as we turn it on. So right now it's kind of settled around 15 milliamps there. If I hit the calibrate button, it puts a calibrate light on, and we'll see the current rise. It'll probably be somewhere around the 38 to 42 milliamps given the situation. That's where it'll end up. The reason it's slow to do this is because there's so many lags in the system here. You've got the tubes themselves. They have a very slow response. Then you've got the bias voltage itself, which goes through capacitors being smoothed out, which also has a response time. So if we look back here, we'll see it's gone to green. That means it's all set, and it's found the bias point at 38.7, 38.6, anywhere around that region. So if we turn the amp off and then we turn it back on again, it'll settle down. If you notice, it's reading low current right now, and once it gets close to its point, it will go green. It's gone green, and the current is going to get up there, but it's 37.8, so 38. But it may have changed. The value may have changed based on the fact that the wall voltage may have changed a little bit. It doesn't use just the current. It's using the voltages inside the amp as well to calculate the best point. So right now that's now operating as it should be. Everything's fine. You could play the amp. If you came to a gig, you turned the amp on and that was showing blue or red, all you would do is press the button. I'll do it just for fun, even though it's on green, and the amp will go through its calibration procedure, and it'll set the current correctly for the operating points. There we go. It's gone back to green. So one of the things that I've built into this system as well is one of the worst things you can do on a tube amp is turn the power off and on again straight away. What this does on this system, This dumps a really low negative voltage onto the bias for 3 seconds once it first powers up, so it'll stop any kind of surge. So if I just do that and that, you find it's really low. Drops right down. So we don't get any crazy surge currents, which can cause it into an oscillation and a runaway situation where the tubes just keep conducting, and eventually the HT fuse blows, which happens a lot. If you've got a 100-watt EL34 amp and you go like that, you're going to blow a fuse pretty much if the amp's hot when you do that. So let's take a step back, and I'm sorry if my camera work's making people drunk. I'm trying to do all this one-handed. So let's say we've got let's pretend we've got EL34s in here. So we'll put this switch up. That tells it that it's an EL34 amp now. So when we start up again, I've got to hold the button. Oh, you get a view of my little guy in the shop there. And it flashes 3 times, so it knows it's got to reset. This time it because of the switch readings, it knows it's EL34s. So it's reading blue. We've got a current, we've got the nice low current, so it's not damaging. And then we'll set off the calibrate button, and we'll see it ramp up. It will be probably, I don't know, 33 milliamps, maybe 29 to 33, depends on the wall voltages. Looks like it's settling in the mid-30s. Oh, 31. Sometimes it's the tubes are still heating up, and the control system's fighting against that offset all the time. That's the exact reason. There we go. It's found its settling point, which is 31.6 milliamps. So that's like it would be as if these 6L6s were EL34s. It set the bias for 31.5 milliamps. So if you saw then, it overshot a tiny bit. What this system, because this system isn't, it might seem very simple when you're biasing an amp that you just turn a pot and the milliamps go up or down depending on what you're doing, but as a control system, it's actually quite complex because there's so many lags in the system. I had to this is a microcontroller, and I've had to incorporate PID control in order to get. I had to write the algorithms because they don't come with algorithms built in. You've got to write it all in code. So I had to write PID algorithms for this control system just so it could respond and didn't overshoot. If you try to do it proportional only by just putting a signal in that's in proportion with the error, it'll start oscillating, it'll overshoot, it'll just get worse and worse, and it'll just go totally out of control. So it needs both integral and derivative as well in order to stabilize it. It seems like a simple system, but it's actually a real pain in the ass, to be honest. But that pretty much summarizes what's going on. So next time you go to a gig and you power the amp up, it'll be all set. I mean, there you can see it's blue, now it's green, so it's happy. That's constantly, that LED is constantly monitoring its operating points, and when it's green, everything is all set. So this is going to be incorporated in the next revision of amps, the next new models that will come out. I'll be integrating this system into it, and hopefully this made sense to a few people. It was probably gobbledygook to many, but guys who have amps know what biasing is and know it costs them a lot of money for a tech to do it. But this system, it allows you to do it yourself, and it allows you to do it completely automatically. Well, thanks for listening. Cheers. Bye-bye.